Good evening, friends. Now we are discussing Introduction to Transportation Problem in module number 3 of the subject Operations Research. What is transportation problem? So it is a special type of LPP. So the objective of this problem is to minimize the cost. So the product has to be distributed from number of sources to different origins. That is to number of destinations. From the production centers to the warehouses or showrooms, the product has to be distributed. So the problem is that from all the sources to different destinations, the products will be shipped. So the cost of shipment should be the minimum one. So here the origin means the location from where the shipments are dispatched. Destination of this problem is the location to which the shipments are transported. So the unit transportation cost means it is the transporting cost of one unit of consignment from the origin to the destination. That is the cost of shipment of one unit from the origin to the destination. So the problem is having special structure, so we cannot follow the usual simplex method, so it is not suitable for solving the transportation problem. So it requires a special method of solution. So the structure of the transportation problem will be like this. So we have different suppliers, supplier 1, supplier 2, 3 till supplier number M. Similarly, we have destinations or the warehouses number 1, 2, 3 till number N. So here the cost of shipment from supplier 1 to destination for one unit. So it is given here C11. Similarly, the cost of shipment of one unit of product from supplier 1 to destination 2 is C12. Like this, so the costs are given in the table. So here number of units supplied from supplier 1 to destination. So X11. Number of units supplied from supplier 1 to destination 2, X12. So here if any supplies are made here, so the cost of shipment is now. So this is for one unit C11. This is number of units supplied. So C11 multiplied by X11. So like this, we have n number of cells in the matrix. So here, after the table, the last row is demand. So this particular warehouse or the showroom number 1 requires B1 number of units. This particular destination 2 requires B2 number of units. So like this, the last destination requires Bn number of units. Similarly, row wise, I have here supply. So the capacity of supplier 1 is that A1. So he can supply A1 number of units. Similarly, the capacity of supplier 2 is A2. So the last supplier M is capable of supplying AM units. The problem will be taken as balanced one if the number of demands will be equal to the number of supply. So the vertical summation, if it is equal to the summation of horizontal demands, then the problem will be called as balanced transportation problem. So we have m number of rows and n number of columns here. So the problem is solvable if we have m plus n minus 1 number of basic variables. As I said, balanced problem means the total supply is equal to total demand. Unbalanced one means total supply not equal to demand. So if the transportation problem is unbalanced one, it has to be made balanced. When supply is greater than demand, a dummy destination is introduced. That is, number of suppliers are more, but demand is less. So we are creating a dummy demand, that is dummy destination. So column, a dummy column is introduced so that excess supply will be going to inventory. When demand is greater than supply, that is demand is more, suppliers are less, means a dummy source or dummy supplier will be introduced in the equation. So if the same transportation problem structure what is given here is written in the form of LPP, so the objective function is to minimize the total cost. So it is summation I is equal to 1 to 3 because we have 3 rows here. So I is equal to 1 to 3, j is equal to 1 to 4. So if 4 destinations are there, j is equal to 1 to 4. 3 suppliers are there, means I is equal to 1 to 3. So here sum of the cost incurred. So as it is shown here, so if the assignment is done here, that is the supplier 1 is shipping to destination 1. The cost incurred is C11 into X11. So like that, from which supplier to which destination it is supplied, so that particular cost will be keep on adding to get the total cost. So this total transportation cost should be minimum 1. So the objective function is to minimize the total cost of shipment. It is subjected to the constraints that, okay, here I have x11 plus x12 plus x13 so on till x1n will be less than or equal to 15. Means there will be the capacity of supplier 1 is 15. So whether it is supplied to destination 1 or destination 2 or destination n. So the summation of all the supplies will be equal to 15. Similarly, we take second row, we have x21 plus x22 so on till x2n. So if I have 4 number of columns, so the last variable is x24 less than or equal to 25. That means the capacity of this particular supply here in total is 25. Similarly, we will write the summation of all this x11 plus x21 till xm1 should be less than or equal to b1. Whether this particular destination get the supplies from 1 or 2 or supplier number m. So the summation will be equal to b1. So like this, we are writing the constraints and all the x values should be greater than or equal to 0. If I don't make any shipment, x value will be 0. If I make shipments, x will be greater than 0. So this is the LPP form. Thank you.